Hi everyone, Dan and I wanted to put together a reference video to show you the end-to-end workflow for using GitHub and Git to create a repository, make some changes on your local computer, push them back up to GitHub, and then also when you're working with others and they're working on a separate machine, how you can merge your changes together using something called pull requests. So to do this, what we're going to pretend is that we're answering an assignment and we're going to create a brand new repository to do that. To help us, however, if you come to the 472 course website and click on the formative problem set, you'll notice that we have this link here to a repository on GitHub that contains a template R Markdown file for you to use. So I thought I'd walk you through this as well during this video. Now, one thing we could do is create a fork off this template repository here. The reason I recommend not doing that in this case is that because you're going to have multiple assignments, you're going to want to have multiple repositories, one for each assignment. But when you fork on GitHub, you can only have one fork per kind of master repository. And therefore, this isn't really going to work because once you forked it for assignment 1, you won't be able to fork it again for assignment 2. So instead, what I'm going to show you here is that you can actually download specific files from a GitHub repository just by clicking through to the file you want. So in this case, the R Markdown file, coming along to the right here and clicking this download button. This is just going to send that template to our downloads folder, and we'll come back to that in a bit once we've cloned our repository to our local computer. So with that in mind, and now that we've downloaded that file, why don't we just go back to the GitHub landing page, github.com, and let's create a brand new repository. I'm going to call this repository 472 _ assignment 1 and give it a short description like, these are my answers to the first assignment. I'm going to make this repository public. That's going to be really useful when it comes to sharing this repo with Dan, who's going to make some changes that we're going to then merge in. I'll add a README file just so that there's a kind of bit of descriptive information on the repository, and I'll leave everything else at its default value. When I'm ready, I'm just going to click Create Repository in the bottom right corner. So now we just have a very simple repository on GitHub, which just has the README file that prints out what we'd entered into the form in the page before. So obviously the next step is to clone this repository onto our local computer so that we can start adding our own files and making our own changes. So to do this, we're going to go to Code, make sure we're on the HTTPS tab, and then copy this URL here. Once we've done that, we can open up our terminal. And we want to work out where to save this on our local machine. Now, when I open up my terminal for the first time, it always takes me to my home directory. And I can see what's in this folder by just typing ls, stands for list, and see the folders that it's printing out. Now, normally I save most of my LSE stuff in this Dropbox folder here, db_LSE. So to get into that folder, what I'm going to do is type cd for change directory, a space, and then the name of that folder. When I press enter, you'll see that my pointer here has changed from tsr to db_LSE. That's just telling me where in my file system I am. And if I call ls, you'll now see that the folders it prints out are different. These are the things that I have in my db_LSE folder. This seems like a good place for me to store that repository. So I'm going to go git space clone space and then paste in the repository we copied from GitHub. I press enter, that clones it, and at some point you'll see it says done. We can check that that's worked by opening up Finder or our file system, going to that folder db_LSE, and you should see that we have this folder now on our local computer. If I go into it, I just have that README file. Now, the first thing I might want to do is to add in the template R Markdown file that we've created for you. So I'm going to go to my downloads at the bottom and just drag in that template folder into the folder I've created using git clone on my local machine. And obviously template's not a very good name because this is an assignment repository. So why don't I rename this to assignment1.rmd. Cool. Now I have this template ready to amend for this specific assignment. So I'm going to open it up in RStudio, and it should look a bit like this. And the first thing that we might want to do is change the title from template to, say, assignment 1. And you'll want to change the author to your student number. Maybe even change the date to something more specific, like September the 29th, 2023. Now I'm going to very briefly walk through what you should see in this template folder and why it's template file and why it's important. So this first code chunk here is the setup. And what this is going to do is change the default behavior so that when you compile this document, it's not going to print out the code where you put it in the markdown file. So for example, if I scroll down, we have this bit of code here, which prints out a plot example. But what it's not going to do is include that code at this point in the rendered document, so the HTML file that we'll create in a bit. Instead, what we have at the very bottom is an appendix and a special code chunk, which is going to gather up all of the code chunks in the file and print all of that code out in one go. So this is quite nice because, like in a report, you might want to show what you've done, but you don't want it to clutter the presentation of your results and your analysis. And therefore you're going to put that all in an appendix at the end. So I recommend you read through this file yourself to see the kind of formatting guidelines and everything that we recommend. But for the time being, we can delete everything that isn't the appendix or this setup chunk. And instead what I'm going to do is just pretend that I'm answering the assignment. So maybe I'll add in a header for exercise 1. And then maybe I'll just add in some text to introduce what I'm doing here. Now, obviously, this isn't actually assignment 1. We're just going to do some very basic changes here to motivate this example. So what I've said is I'm going to present the results of writing a for loop that prints out the numbers 1 to 10. To do that in an R Markdown file, we need to create a code chunk that runs some R code. So to create that code chunk, I'm just going to insert 3 backward-facing apostrophes, then some curly brackets, tell it the language I want to use, which is R, and then I'm going to give it a name, the code chunk a name. This is just going to help us refer to it later. So, for example, exercise 1. Now to close this code chunk, I'm just going to copy and paste those 3 backward-facing apostrophes to delineate what is code and what is text. So this is text, and this is code. Okay, so I don't actually want to put that. What I want to do is a for loop. So for I in 1 to 10, curly brackets, print I. And make sure you add a code comment so it's clear what you're doing. Excellent. Then underneath, maybe I'll just say, this prints the numbers 1 to 10, each on a separate line. Excellent. So suppose this is kind of where I want to get for the day, and I'm ready to save this document, compile it just to see how it looks, and then send it off to GitHub. So the first thing I'm going to do is I'm going to press knit here, and this is going to take the R Markdown file and generate on the right hand side here, or maybe in a new window for you, the compiled version of that in HTML. So let me just point out some key features here. Obviously you've got the title that we changed it to and your student code. We've got this subheading for exercise 1 and our text, but we've also only got here the output of our code. So literally just it printing 1 to 10. you can't see the code here. And that's what we want. We want to keep our presentation and an analysis as clean and succinct as possible. But notice in the code appendix, it does find that code and it includes it here. So I can still see how this was generated at the bottom of the document. Excellent. So now if I just come back to my Finder, I should see that I have both the R Markdown file that we amended, and then also the knitted version, the HTML file, which is what you would submit to us via Moodle. As I said, we're going to pretend that this is enough for today. So we're going to come to Terminal, and we're going to want to stage those changes and then send them to GitHub. The last time we were in Terminal, remember, we were just cloning the repository. So we're in the folder that contains our repo folder, db_lse. If I run ls again, you should see that we have this folder here, 472_assignment1. To commit the changes, we actually need to be inside this folder. So I'm going to do cd for change directory, space, then the name of the folder, enter. Now I'm inside that folder, and if I press ls, you'll see I got the 3 files that I'm expecting. And then we can stage those changes. So say these are the files that I want to kind of commit to our version history by saying git add and then a dot. The dot means add everything. Enter. Then we can take that snapshot by writing git commit and then a message. So -m and then in quotation marks, I'll call it setup assignment 1. Enter. Now we've taken that snapshot, including changing the files and adding some insertions. Okay. We might want to send that off to GitHub. And that's very easy. We're just going to type git space push. And after a while, you should see that this has gone through. We're pushing from the main branch of our local repository to the main branch of our remote repository, which is our GitHub repo. If I come back to GitHub now and refresh this repository page, you should see that we have alongside the README the R Markdown file and the HTML file. And that R Markdown file contains our preliminary answer to exercise 1. Now this is great. So we know how to push this back and save a version of this on GitHub. But suppose this is an assignment where we wanted you to collaborate with others. How are you going to get your collaborator or peer in the course to make some changes to these files and then send them back to you in a way where you can easily merge those changes together? And that's going to be the focus of the second half of this video, where I'm going to ask Dan to make some changes and then submit a pull request back to me so I can assess those changes and then merge them in. Now, because Dan is going to work off a branch of this repository, and he's going to want to push that branch up onto GitHub too, he needs to have access to my repository. Now, this is really easy to do in GitHub. So from the repository page, go to settings. And from settings on the left-hand side here, come down to collaborators. And then you manage access, add people. And here you need to know the username of the person you're adding. In this case, I know Dan is under DeCat. I can click his name and then add Dan to this repository. Now, once Dan has access and accepts my invitation, he'll be able to push his changes to his branch on this repository, and then we can reconcile any pull requests he submits.
Okay, so Tom has shown you the creation of a new repo, editing some of the files in that repo, pushing those changes up to GitHub. And now what he's done is he's invited me to collaborate on his new repo, which you saw him create, 472 assignment 1. Now, collaborating with him on this repo means that he and I are both going to be code owners. We're both going to be able to make changes, approve changes, edit the repo. We will both be able to essentially do whatever we want to this repo. Now, that's not the only way of collaborating. So you've also heard us talk about forking. Forking is a different way of collaborating. Forking is a way of collaborating in which we make a copy of the repo. We're going to focus today on collaborating through shared ownership and branching, but I will show you forking for a moment as well. So the first thing I'm going to do is I'm going to accept Tom's invitation because I'm very polite. And that's going to take me to the repo that Tom has shared with us. Now, as I said, we could fork this if we wanted to create an entirely separate version of the repo, and then I would be able to work in that repo. Tom would work in this repo, and we could potentially go in entirely different directions. There are also ways for us to then reunite our forks. I can, for example, track his fork and receive all the updates he makes to his fork. Likewise, I can send pull requests to Tom and ask him to approve them, which would then change the upstream repo, which would be his. Now, if we wanted to fork, we would click here, we would fill out some information, and we would create a fork. We're not going to do that, as I said, but you've seen Tom do that potentially before, or we talked about it before. These are both valid ways of working in collaboration. There are upsides and downsides to either. A fork is going to be particularly useful if you're collaborating with somebody you don't really know very well. In other words, you don't want to let somebody have total access to your repo, but you are happy for them to mess around with your code, potentially push updates that you get to vet. So, for example, if you're doing open software development, say you're developing a package for R or Python or working in some other part of the open software space, forking is going to be a principal way you allow other people who you don't necessarily know, they're not part of your organization, they're not part of your team necessarily, but it's a way to let them collaborate and make suggested changes to your repo. The downside of forking is that it creates lots of repos. So it creates kind of duplication of code. Instead of having a single code base that Tom and I are working on together, we would now have two separate code bases that we would each be manipulating. Reconciling those code bases is more challenging from the fork perspective than it is from a branch, as we covered in class already. So for the types of projects you're going to do while you're at LSE, branching is probably the way you want to do it, collaborating and then branching rather than forking. What we mean by that is when you're working with a partner on your project for this class, or when you're working with an advisor on a project, or when you're working with somebody else at LSE, you're going to simultaneously own and collaborate on the same repo rather than forking it. If, however, you want to work in open data science space, for example, forking is going to become more important. But that's as much as we're going to say about it for now. Okay, so we've just been made a co-owner, collaborator of this new repo. That's great. Tom has done all the setup. You've seen him do that already. So the first thing we're going to do is something that you should all be becoming familiar with. We're going to clone into this repo on my local machine. So how do we do that? We click the green button there and we find clone, make sure we're in the secure HTTP setting. We copy that and we move to our terminal. Now, I'm using Windows, I'm not using Mac, so I'm using git bash. You could use PowerShell or something else if you want. I'm just using git bash for now. Now, I've already done some setup. I've put us into a particular folder in my drive or in my computer already. Let's see where we are. So we're in my Department of Methodology Dropbox folder in my personal drive, and there are two folders that I can access, personal or public. I'm going to take us to public because I don't want you to see what's in my personal folder. It's personal for a reason. So we'll move into public. Now, let's see if there's anything in public. No, it's empty. How can I do that? Well, trivially, I can just open this file and mess with it, right? I can open it in R, I can write things into it, I can do all sorts of stuff. But that's not the process we want to follow, right? The process we want to follow is sort of hygienic Git behavior. So the first thing we're going to do is we're going to check where we are and what's going on in status. Oh, we're not in the repo. What do we need to do? Find the repo, move to the repo, amend one, and now we can check our status. Our branch is on, we're on main, obviously, we haven't created a new branch. Our branch is up to date. Everything looks good. Now what we want to do is we want to create a new branch for us to make some changes that we'll send back to Tom. But before we make a new branch, we always want to write git pull, which essentially pulls from origin, that's the cloud, to our local machine to make sure that we're actually up to date. Now we know that we're up to date because we just ran git status, but it's always hygienic and smart to write git pull anyway and run it. Nothing bad's going to happen if you do that. It just says already up to date. Now we can think about creating a new branch. How do we do that? Well, we use git checkout -p for create a new branch, and we give our branch a name. We're going to work with the branch called development. Now we can check our status again if we want, git status, but you can already see that git bash is giving us some helpful clues. It tells us the branch we're on over here, which is already very nice. We're on branch development. We haven't made any changes. There's nothing to commit. Everything looks clean. Now we'll move back to the local drive. So let's start playing with assignment 1. That can go away. So here is assignment 1. Those of you who've already seen Tom edit this will have seen exactly what is in here. He's set up a nice little document. He's put in a loop that prints out the numbers 1 to 10, and it all runs just fine. Now, what are we going to do? Well, we're going to make a change to this. Let's make a change and say instead of printing just from 1 to 10, we're actually going to print from 1 to 20. And to do that, we're going to need to change the code. We're also going to need to change the actual. We could do anything else we want. We could create a new code chunk if we want. We could create a new section. In fact, why don't we do that? Let's create a new section for exercise 2. And here I will I'm going to print 10 random numbers from uniform distribution. So just like Tom did before, we're going to have to set up a code chunk. I'm not going to type it all out. I'm just going to use the power of copy and paste. Make sure that I change the code chunk name to exercise 2. And now I'm going to need to change the code too. What are we going to do? Well, we want to draw 10 numbers from a uniform distribution. That's our unif. And we will draw 10, and we'll leave the other parameters set as they are. Let's add a little comment. Okay. Now, one thing you can do that's quite nice when you're working in R Studio, in R Markdown, is you can just run the code chunk to check if it works. And so it does. We've just drawn 10 random, pseudo-random numbers from uniform distribution. Okay. Now we can finish writing. We can say, this drew 10 random numbers from the uniform distribution. And we are done. Now, if we just leave it there and we go back to the command line and we type git status, what do we see? Well, turns out no changes have been made. That's mysterious. Why have no changes been made? Well, the reason is we haven't saved the file locally. I dwell on this because this is a mistake we all make all the time. We don't save our files necessarily as often as we should. And if you haven't saved this file, well, then the drive has not locally updated. There is no change. So I'm going to Control S save. So click the little floppy disk and go back here. Try git status again. And now we can see we actually have modified our Markdown file. So now what we're going to do is proceed as we've done before. We're going to stage this with git add status. Now we know changes to be committed. That means we've staged correctly. You can unstage if you want. You can take that away. But we're instead going to move toward committing. So we're going to say git commit. We're going to give a little message, and our message will be completed exercise too, so that Tom knows what we've done. All right, we get a nice little bit of feedback. We're on development still. We have completed exercise 2. That's our, we've completed exercise 2, and we've changed one file. That's right, just one file. We have made 16 insertions and 3 deletions. Why have we made 3 deletions? Well, remember, we changed Tom's answer to exercise 1 by making it count to 20 instead of just 10. We did that 3 times on 3 separate lines. So those lines have now, in Git's mind, been deleted and reinserted as different lines. So now we can check our status again. On branch development, nothing to commit. Working tree is clean because we've committed all of our changes. What happens now if we check out main? Look at our status on main. Main is clear, nothing to commit. Excellent. Now what we want to do is hit push. Oh, I'm sorry, I'm being silly. We want to go back to development. So git checkout development. Okay. Now we want to go git push. Now, Git doesn't like that we've tried to push branch development to main because we haven't actually set what's called an upstream branch yet. The way to do that is pretty straightforward. It tells you exactly what to do. We just need to type in set upstream to origin for development. In other words, we're setting the upstream branch for the development, the upstream for the development branch to the origin online. So we will copy that and we will run it. And now our push will go through. Okay. Now, we can move back to GitHub. If we move to GitHub, we suddenly see that something new has appeared. Okay. Development, that's the branch that we've been working on, had recent pushes less than a minute ago. So now we're going to compare and pull request. You can also access it from up here, pull requests. Okay, compare and pull request. This is the template for a pull request. Okay, and essentially what this pull request is saying is it's saying to Tom, I would like you to have a look at what I've done and then decide whether you're happy to move development into main, to merge it in. Okay, so merge them in. Now, this was the little message that I created, completed exercise 2. That's not a super informative title because it's not formatted properly. X2, what does that mean? So instead I'm going to say completed exercise 2. And then I'm going to say this PR completes exercise 2 in the assignment. Note, I have also made a small update to exercise 1. That update was to increase the number of numbers presented from 10 to 20. Now I can click create pull request. Before I do that, I just want to emphasize that if you're using pull requests, this is really important. You actually want to put proper documentation here and information for the person who's going to review the pull request. If I just leave this blank and Tom receives a PR from me, then he needs to figure out what on earth I've done. This is pretty straightforward. I've told exactly what I've done. We completed exercise 2 in the assignment. We've also made a small update to exercise 1. We've told them what the update was. So now we click pull request. Create pull request, and we have created a pull request. Okay. Now, the pull requests that we're in now, so now if we click pull requests, there's no longer that thing at the top. Now we actually have a pull request right here. You can see it's an open pull request. The branch has not been merged into main. So we can go to it and have a look at it. Now, GitHub gives us lots of nice functionality here. So number 1, it shows us all the commits for this pull request. We'll add another one in a moment, maybe. It also shows us the files that we've changed. Now, this is kind of neat. It shows us essentially all the changes. It's shown us that we removed that line, which had the 10, and instead we added another line with a 20. It shows us all these new additions down here. And that's nice because now Tom can come and actually look at this and basically see literally exactly what we've done. There are different ways of viewing this. You can sort of view it side to side. You can do all sorts of different things, but this is sort of one of the nicest ways to view it. Tom might show you sort of what you can do here. You can add all sorts of comments. So he might not like the fact that I've changed this, or he might not understand why. So he could, for example, add a little comment at this line and say, Dan, what are you doing here? You've doubled our workload. All right, and then he could add a single comment. Now that's going to be a comment from me at line 19, but Tom could do the same. And you can already see why this is powerful as a review feature. You can literally go through someone's code and add comments, and then that person can resolve the conversation. Now, one other thing I can do, and I'm just going to show you this very quickly, is I can, so this is sort of the review functionality, I can actually edit the file directly here using GitHub's own editor. Now, I wouldn't recommend doing this very much, but if you have a very small change, like say you've just submitted this PR and you realize that actually there was a typo in the PR, that we sort of should have added something extra here. We should have said, this completes the second exercise. Okay, you can then add that here, literally, and you can just commit changes. Now, this is going to be a new commit, so we'll just say corrected missing text, add an extended direction if you want, and now you can commit it directly to the development branch. Let's see what that does, commit changes. Now, you will see up here in the same PR, so we're still working in the same PR, we haven't created a new one. Now we actually have two commits. We have the basic commit that created the actual PR, and now we have this corrected missing text. If you go to files changed, all you will see is the updated version. You won't see the version that I changed, because what I want Tom to do is review the entire PR, not review every commit that creates the PR. Okay, once I'm happy with the PR, I'm going to now what I could do, right, because I own this repo along with Tom, I can actually just merge this directly into main. Okay, I can just do that, no problem. No issue at all. I can also then just delete development branch if I want. But I'm a responsible user, so I'm not going to merge that directly into main. Instead, I'm going to request that Tom reviews it. So I'm going to click request. Tom has now been emailed and has been asked to come and review my pull request. So what Tom is going to do now is he's going to open up this pull request, review it, make some comments if he wants, and then when he's ready, he can merge that pull request into main and remove, if he wants, the development branch, and we are all up to date. Now, it's probably wise for me on my system to move back to main. So I will go git checkout main and leave it there.
All right, so it's a bit later on in the day, and I've just had this email through from Dan requesting my review on a pull request. So first things first, I'm just going to click through this link, and this should just take me straight to the pull request that Dan has submitted. So clearly here I can see what he's done, and he's left me a few notes, so let's just check those out. So this pull request is going to complete exercise 2. Great, we didn't even start exercise 2 when I was working on it, so this is progress. And he's also made some small updates. So why don't we, I can see that he's written a comment here, but actually I can see this in the code as well. So I'm going to just, first of all, shoot to commits, just see roughly what's going on. Okay, he first added exercise 2, then he corrected the missing text. All right, cool. Let's go to files changed. I think this is the most informative bit of the portal. And here on the left, I can see my code. And on the right, I can see how Dan has changed it. And GitHub is going to try and make this as concise as possible, just so I see where those changes are. So I wanted to go from 1 to 10, but Dan wants to go 1 to 20. And in fact, I'd already had a sneak peek of this. So I'd already replied saying it's all good, best to be thorough. So I'm happy with that change. That looks good to me. Why don't we resolve this conversation? Here, Dan has actually changed my code from 1 to 10 to 1 to 20. That makes sense. That's consistent with the text. And he's added in this exercise 2 here. I'll just have a quick look at what he's doing. Okay, so it's 10 draws from the uniform distribution. Run if is indeed how you do that in R. So I'm happy with that. And we've got a nice little bit of discussion at the end here. So I'm really happy with this. I think this looks great. And I'm ready to merge all of this in. So the first thing I'm going to do, since Dan requested a review, is I'm just going to tick this to say I viewed it. Okay, it's just a way of tracking that if you had multiple files that have changed, you could just make sure that you've checked every file that's changed. That's fab. And then I'm going to go to review changes here. And I'm just going to leave a comment that says, looks great. Thanks, we'll merge this. So Dan's aware that I've had a look through and I'm happy with the changes. So instead of commenting, I'm going to approve this, right? This is saying I'm happy to merge these changes and I'm going to submit the review. This takes us back to the kind of headline conversation. So you can see that you've got the original stuff, what Dan commented, and the fact that I resolved it. Dan requested the review. I've said this looks great, thanks, and we'll merge it. And so now we can do that merge. And to do this, I'm just going to come down here and select Merge Pull Request. Now this is a commit, so I need to actually describe what we're doing here. Completed exercise 2 and updated text and code in exercise 1. Let's confirm that merge. And now you'll see that it's gone purple, okay, and said that the pull request has been successfully merged and closed. So GitHub has said, okay, you've actioned everything. You don't need this pull request anymore. You're fine to kind of go ahead. So we're all set. And what it's suggesting what we do is delete that development branch. Now I think that's quite a good idea because we want to kind of collapse our repository tree back to the simplest form we can. Development was just used by Dan to answer exercise 2 and make some small changes. He's made those changes and he's asked me to merge them in. So since we've done that, we can safely delete it. So I'm just going to click delete branch here. Fab. Now, just very quickly, let's do 2 more things. Let's go back to the main repo page and see the code. And notice I'm back on main. And if I click here, the only branch is main. That's because we just deleted the development branch. If I look at that assignment 1 file, you'll see now that it has Dan's changes, 1 to 20, for example, and here's exercise 2. So that looks great. But actually one thing that's not changed is the actual HTML file. Notice that this was last changed 3 hours ago. That's when I originally knitted it and uploaded it. That's because GitHub isn't going to say, oh, that's an R Markdown file, I should knit it to update the HTML. You have to do that manually. And that's going to be really hard to do on GitHub. So instead, why don't we make that change locally and then we'll push up to main again. So I'm going to come to my terminal. Now I've already had my terminal at the same place as when we were last creating this repo. So I'm already in the right folder, but just make sure that you know where you are before you do this. And the first thing I'm going to do, now that there's been some changes to the main repository on GitHub, is pull those changes down with a simple call to git pull. So what it's saying here is that it's looked at the changes or the deltas, okay, and it's pulled those changes down from the GitHub repo into my local repository and fast forwarded those files on my local machine. So in particular, it's updated just the R Markdown file, which is what we saw Dan had changed. So now I'm just going to go to my Finder and I'm going to open up the folder on my machine and open up the newly changed R Markdown file. We'll see that this has the changes that Dan implemented. And the last thing I'm going to do is knit it. So hopefully we should see on the right hand side of my screen in a second that now, there you go, here's the numbers 1 to 20, and here are the random uniform drawers that Dan added as well. And just for the sake of illustration, look at our appendix now. It's got both the for loop from my initial commit, but also the code that Dan added for the hypothetical exercise 2. So this looks great. So now I'm just going to do one final thing, which is come back to my terminal. And since I've now changed that HTML file, I'm going to just stage that change, commit it with an informative message, renit HTML, and then I'm going to push that back up to GitHub with git push. And when I do that, and I come back to the assignment repo online and just refresh it, you'll see now that my HTML file was updated literally seconds ago. So it says it was updated now. If we look at the commits, you can see that you've got the initial stuff I did, the commits that Dan made and that I then merged in, and then that final change where I updated the HTML file, which is what you would then submit to Moodle. So I hope that's helpful. If you have any other questions, you know that you can contact me and Dan during our office hours or in the seminars.